Good call. All right, here's the integral we're going to do from WebAssign. We're going to do it with the trig substitution. We're going to let t equal sine theta. The derivative then is cosine theta d theta. I'm going to change the limits of integration. When t is equal to 0, theta is equal to 0. When t is equal to 1/2, theta is equal to pi over 6. Now I'm going to make the substitutions. 0 for t, theta is 0. When t is 1/2, theta is pi over 6. T squared, that's sine squared. 1 minus t squared, that's sine squared to the 3/2. dt is cosine theta d theta. Okay? So what do we have here? We have 1 minus sine squared, cosine squared. Cosine squared to the 3/2. The 2's cancel, you get cosine cubed. So right now we have this. Here's what we have. Sine squared, cosine cubed, cosine. That's what we have right now. Okay? Well, this cosine can cancel out one of those. 0 to pi over 6. We have a sine squared over cosine squared. Well, what's sine over cosine? Tangent, that's the way, Danielle. Okay, that's a tangent. We've got a tangent squared here. So pi over 6. And how are we going to do the integral of tangent squared? I think we did this last class. And what we had to do this was to do a substitution here. Tangent squared is equal to what? What's that? Oh, okay. Tangent squared is secant squared minus 1. And the reason for making that substitution is because we can do the integral of secant squared. The integral of secant squared is? Nope. Integral of secant squared is? Tangent.
Could you do it a different way?
I'm sure we can. Hold on, let me finish it this way and then we can do it a different way. Tangent theta minus theta. Okay, and then from 0 to pi over 6.
Why is it minus theta?
Because the integral of 1 d theta is theta. Substitute in the tangent of pi over 6. Tangent of 30 degrees, 1 over the square root of 3. Square root of 3 over 3 when you rationalize it. Okay. Minus pi over 6. Zeros give us 0. I don't know, what would course compass want out of this? Maybe 2 square root of 3 minus pi all over 6. Wow. But, you know, Nick, I'm not sure what they want. I'm not even sure what they're asking for. Did you already do this one, Damien? This problem in there?
I didn't do it on the other side.
Oh.
I did it other ways.
Well, all right, what was your other way?
I could change sine squared into 1 minus cosine squared.
True. We could do 1 minus cosine squared here. And then you have 1 over cosine squared, secant squared. Cosine squared over cosine squared, 1. Guess what? You end up with secant squared minus 1. That's nice. That's nice. Nick, I don't know what to tell you, except this is the answer to the integral.
Put it in right now? Yeah, I'm gonna.
Yeah, put it in somewhere and see what they say.
You could just overwrite it, right?
Oh, I can just give you credit. Yeah, I can do that because it's not clear to me what they're asking for in the first.
Yeah, that was it.
That's right.
Yeah.
Wait, the last answer two for
Yeah, that, yeah.
Yeah, okay. All right. There you go. Any other questions on homework?
Yeah.
Go ahead.
All right. This is probably going to be an easy question, but.
Hey, whatever.
How does cosine theta plus 1 over negative sine squared theta set it equals negative cosecant cotangent minus cosecant squared d theta?
What? All right, so you want to change this
Yeah.
into, okay, so it's cosine over negative sine squared. See this minus thing? I want to take the, is this an integral?
How did I do that?
Probably is an integral, huh? But,
It's like, it was like in the middle of a problem.
okay, well, here's the deal. See this negative? I'm going to take this out front. I'm just going to throw that away. You got cosine over sine squared. Let's take a look at that. Plus 1 over sine squared. Okay, it's the opposite of all that. This is cosine over sine, 1 over sine. Now, 1 over sine is cosecant, so this is a cosecant squared. I think this is what you had.
Yeah.
This is a cotangent,
Cosecant.
and that's a cosecant.
Okay.
Yeah,
Yeah, I wasn't sure how to split it up.
that's one way to do this thing.
Okay.
It's a pain in the neck.
That makes sense.
Yep. All right, any others? Gessner. Uh-oh, this is complicated. He's got to come up and give it to me. Oh, man. This is like one of Melissa's. Give me this.
I'll just to see if I got the solution first.
Sine cubed, let's do it. This is a test question, possible test question. Yes,
So what happened with the negative?
I threw it away. I just said it's not relevant here in what he wanted me to do, so I just tossed it. Okay. All right, so this is the problem, sine cubed. And like I said, this is a possible test question. This kind of thing is one thing you might certainly see on the test. High probability. What you want to do with sine cubed is split one of the signs out. Okay. Split one out. What remains is a sine squared, which you will change to cosines. Pythagorean identity. Okay. And then multiply this out, so we have the integral of sine minus cosine squared sine. Okay. And now the integral of sine you can do, the integral of sine and negative cosine, minus, now this is a u to the n form. U is cosine. The du is a negative sine. I'm going to multiply by -1 here and make this a positive.
Where's that negative cosine x coming from?
The integral of sine. Okay. And what I have over here is a u to the n du form. It's u squared, the integral of which is u cubed over 3. So it's cosine cubed over 3 plus a constant. That's what you should have, Gessner. Okay.
And it's not negative?
No, it's not. The u is cosine. The du is a negative sign. We had to get a negative in here to get the du. That changed this net minus to a plus. And then it's u squared du, and the integral of u squared du is u cubed over 3. And that's what it is. It'll be plus. Okay? Okay. Any others? Anything else at all?
I really get what happened to the negative sine x still. I get the interval you got for cosine, but
Okay. All right. So this one right here, this negative sine
I
x,
just don't get what happens to it. Like,
what happens to this is this negative sine x dx is du. Any others?
Can you say that one more time? What the du is equal to?
Negative sine x dx. So you replace this negative sine x dx with du. See, this integral becomes the integral of u squared du. That's what this integral becomes after you multiply by -1 here to make sure you get the du. And that is the goal in doing all these integrals. You want to end up with an integration form that we have, u to the n form, with at most the introduction of a constant, and I can multiply by -1 to make sure I get the du. I can do that, as long as I compensate by multiplying outside by -1, making that minus, which was there, a plus. It's u squared du. Where's the sign? It's in here. It's in the du. Okay, that's where it is. How's that look? And away. All right, any others? Okay, go ahead.
Integration of x squared over square root of 36 minus x squared.
Just like this? Okay, that is very similar to the first one I did. Here's what we're going to do. This is going to be a trig substitution. And the reason it's a trig substitution, it's close to being other things. If this were an x instead of an x squared, it would be a...
Squared?
Yeah, yeah.
You can see it.
Oh, you can?
Just the squared part.
What the heck? All right, okay.
Substitution then.
What's that?
I thought it was just direct substitution.
It is a trig substitution. That's what I'm going to do.
Yeah.
Okay, but here's what I'm saying. I mean, it's close to being other things. If this weren't an x squared and just an x, it'd be a u to the n form. If we didn't have an x squared at all, it'd be an arc sine form, inverse sine form. But it's not those. So the only way to do this is with a trig substitution. And that trig substitution is to let x equal 6 sine x, 6 sine theta. So dx is 6 cosine theta d theta. Okay. This is a squared minus u squared. And you're going to let u equal 6 sine theta. On the test, I may give you an integral like this, but what I'm going to ask for in the test is what trig substitution should be used. Your answer is x equals 6 sine theta. That's it. That's your answer on the test. Can you? I know it's babyish, isn't it? You think I should change that?
No.
No, I'm not going to change it, okay? All right, but we're going to do the whole thing out here. So what do we got? X squared. Square root of 36 minus x squared dx. Take a 36 out. It comes out as a 6. It will cancel that 6. I'm going to take this 36 out front. I've got my sine squared here. I've got a cosine here. Inside here, I've got a 1 minus sine squared. That's cosine squared, the square root of which is cosine.
Where does that 6 go again?
Excuse me?
Why did you get rid of the 6 for the cosine?
Because a 6 comes out of the square root and cancels
I thought you
that.
just separate them. Like,
Well, you can factor out a 36 and 1 minus sine squared here,
Okay.
but it's inside the square root. When you take it out, it's a 6. Okay. So what happens now? Cosine cancel. And I have 36, the integral of sine squared. Yep. Now, how do you integrate sine squared? Well, 1/2. The integral of 1 minus cosine 2 theta, the hand-angle substitution. That's how you do sines and cosines to even exponents. This is 18. The integral of 1 d theta is theta minus. This is cosine u form. U is 2 theta. Go ahead. Yeah, exactly right. That's exactly right, Kestner. Du is 2d theta. I'm going to have to multiply by 2 to get the du part, but I'm also going to have to compensate by multiplying by 1/2. Okay, does everybody see that okay? I've got 1 d theta, the integral of which is theta. That's no big deal. And then I have this integral of cosine 2 theta d theta. U is 2 theta. Du is 2 d theta. I got to multiply by 2 to get my du, but I also have to multiply by its reciprocal 1/2. So I got 1/2 cosine u du. The integral of cosine u is sine u. Okay? That is your answer. Of course, WebAssign may have you multiply through by 18. I don't know. But that is the correct answer right there. Okay. What else we got? Anybody else? You all set, Nick?
The YouTube video, apparently it did put it on YouTube, it just didn't make it public.
It didn't make it public?
Yeah, and like, remember like you didn't check it off on your thing, the same thing with YouTube?
Okay. So now it's public? So I'm out there now?
Yeah, I guess.
So we're gonna go viral and all? Yeah.
Trent.
Got a million views.
Yeah, all right. What's that?
Got a million views.
A million views, huh? The only way it's going to get a million views is if I stay up all night and do about 10,000 views. Yeah, that's about right. Go ahead.
Just put that back up.
Oh, sure. All right, we ready to go on? Okay, let's do partial fractions.
Subscribe.
You all set it? All right. No sweat. All right, let's do a partial fraction problem. Let's do one similar to what we did last time. Let's do a problem like this.
Take to the top.
Here's the integral to do. Okay. The way to do a problem like this rational expression, where the denominator is factored here into two linear factors, is with partial fractions. What we're going to do is take this fraction and rewrite it as the sum of two fractions. Okay? Now, there are two ways to get this a and the b, the two constants here. There is a long way, which I'm going to show you again. We did it last week as well. And then I'm going to show you the super fast way. Okay? The super fast way is the best way to do it, but I'm going to show you the long way first. To add these two fractions, you need a common denominator. The common denominator for these two is their product, x minus 1 times x plus 3. If you were to add these two fractions up, you would multiply this numerator and denominator by x plus 3. You would multiply this numerator and denominator by x minus 1. You would end up with an ax plus 3a plus a bx minus b over x minus 1, x plus 3. What you should do here is gather your x's. Okay? I've got an a plus 3 x's. And then I have constants, 3a minus b. Okay? Now, if this fraction is to equal the original fraction, their numerators must be equal. This fraction has a plus 3, a plus 3, a plus b, sorry, this is a bx minus 1, bx minus b, multiply it through, okay, it's a plus bx, okay? Everybody okay with that?
Wait, what did you say? So the denominator has to equal the numerator?
Well, the denominators are already equal. The numerators are going to have to be equal. If these
What?
each other. This one would have to equal this.
How?
Well, let's see how. That's a good question. How is that possible? Well, what we're going to do is set the number of x's in this numerator, and I've got 0 x's in this numerator, equal to the number of x's in this numerator. I have a plus b x's in this numerator. Therefore, a plus b has to equal 0, since I don't have any x's here. If this numerator had been 7x plus 1, say, a plus b would equal 7, the number of x's that were here. Okay? I got to tell you something else. If this numerator were x squared, you can't do this whole process. Notice there's no x squares here. What you have to do in that case, if this is an x squared, can anybody tell me what you'd have to do first in this problem?
Multiply the bottom by x.
No. What's that? Divide is absolutely correct. If the degree of the numerator is equal to or greater than the degree of the denominator, what you must do is divide first. You'd have to do a long division first and then work on the remainder. Some of these problems can be amazingly long problems to do, okay? But I'm not going to give you anything like that. Certainly on a test I wouldn't, okay? All right, a plus b must add up to 0 since there are no x's here. My constant over here is 3a minus b. That must equal my constant here, which is 1. Okay? We get 2 equations and 2 unknowns. Easy enough to solve. Set up, add them up. B's cancel. Solve for a. If a is 1/4, b is a negative 1/4. Okay, go ahead. Make sure everybody's okay with this.
What happened to the a plus b?
Nothing, but when I added these two up, the b's canceled out.
Why did you add them together?
So that the b's would cancel out. That's addition method, solving
Did you
two.
factor it out, or?
No, just add them up. A plus 3a.
I guess I'm just missing the step before that, I guess.
Well, the step before this one is this one back here, where I set the x's equal to the x's and the constants equal to the constant, 1. Since there are, you can think of this as 0x plus 1. A plus b must add up to 0. 3a minus b must add up to 1.
And then you just equal, okay.
And then you got a system of equations to solve. But they're already set up nicely. Yes?
Is b always a negative a?
In this case it is. If a plus b adds up to 0, it is. But that's not always going to be true. A plus b could be 7, like I said, if we started with a 7x up there. Okay? You just have to solve it. Okay. So what do we have? We have this now. This integral becomes this integral. A plus b dx. These are two simple integrals. Okay?
Oh, you kept closing it?
Okay, so what do we have here? We have 1/4 natural log x minus 1, 1 over u du form, minus 1/4 natural log x plus 3 plus c. That's a correct answer. It's a little bit nicer answer to take a 1/4 out. The difference of two logs is the log of their quotient. That's probably the best answer here. Like so.
Can you put down a little bit?
What's that? Move it down? Up?
Oh, up. That's what
Yeah.
I meant.
Okay, no problem. There. Now, yes?
My answer, I got ln x minus 1 over 4 minus ln x plus 3 over 4 plus, is that, I'm not really exactly.
Yeah, if you put the ln all over 4 and this ln all over 4, yeah.
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 Okay.
Okay, that's one way to do the problem. Yes?
After you show the easy way, can you show another example that's something much harder?
Well, we got two other we're going to have two other ones that are going to be more difficult. This is the easiest of the three. There are 3 possibilities.
Oh, of solving the same problem?
No, of using partial fractions. This is the easiest one where you have the product of 2 linear factors. The next one I'm going to do is the product of 2 factors, one of which is repeated, like x minus 1, x plus 3 squared. That would be a much more difficult. That'd be a more difficult problem.
And that's the 3 things you're going to do today.
And then the third one is x minus 1, and the other factor is x squared plus 4, say, something that's not factorable.
So these all 1 over those.
Well, I'm going to change this 1 to some other things.
Okay.
I'm going to make it more complicated as we go along. This is the simplest one.
I'm just thinking of my method.
You're right. So, how are we doing so far? All right, the next thing I'm going to do is show you the easy way to do this, okay? I'll show you the easy way. All right. right, as soon as we get people. I'm losing people here, left and right. What's going on?
Adrian, wait for me.
All right. All right, same problem. I'm going to take this fraction, 1 over x minus 1, x plus 3. Okay? Is equal to a over x minus 1 plus b over x plus 3. Now, watch this, because this is somewhat magical how this works, okay? Here we go. I'm going to solve for a first. I'm going to solve for a first, yeah. But I don't want to do this without Nick.
You can watch the video.
Oh, no, that's not right. That's not right.
Well, you showed us last week.
I did show you last week.
Yeah.
All right, fine. All right.
You'll be okay.
There he is. All right, Nick. Good deal. All right, I just didn't want you to miss this. I know I already did this, but I'm doing this the super fast way now. Okay? All right, so here we go. Here's how you do it the super fast way. I'm going to multiply both sides by x minus 1, this denominator. I'm going to cover up this x minus 1 because when I multiply by x minus 1, this will be gone. It will be canceled out. And then I'm going to let x equal 1. When I let x equal 1, this will be 1 plus 3, 4. I'll get 1/4 on this side. Now what happens on this side when I multiply by x minus 1 and let x equal 1? Well, this x minus 1 cancels out. I'm left with an a here.
Would it be a over 0?
No, the x minus 1's canceled. It's gone.
Yeah, but if it's 1 minus 1, is that 0?
Yes, but I multiply by x minus 1 first, and the x minus 1's will cancel out. Then I'm going to let x equal 1.
Oh, okay. So they
Okay?
don't exist. Okay.
All right, so it's gone. Now I'm going to multiply this by x minus 1. And now I'm going to let x equal 1. This is a 0. This whole thing is now multiplied by 0. It's gone. I get a equals 1/4. Which is what after this, we got a.
I don't see where the 4 came underneath, because isn't
The
1 minus 1 0?
Yes, but I multiply by x minus 1 first, so it's gone. And then I let x equal 1.
Okay.
1 plus 3 is 4. Okay? Now, I'm going to multiply by x plus 3. I'm going to multiply by x plus 3. This is gone. And now I'm going to let x equal negative 3. Negative 3 minus 1 is negative 4. I get negative 1/4 here. What happens on this side? When I multiply this by x plus 3 and let x equal negative 3, this is multiplied by 0. It's gone. When I multiply this by x plus 3, the x plus 3's cancel. I get b.
Where did you get the negative 1/4 from?
Over here, after I multiply by x plus 3, I let x equal negative 3. Negative 3 minus 1 is negative 4.
Where does the negative 3 come from?
That's what I do. I let x equal negative 3. I multiply by x plus 3, and then I let x equal negative
So
3.
it's always the opposite.
Yes, it's always whatever makes it 0. Okay? How are we doing? Everybody okay?
Then why doesn't A have anything in front? Why is the 1/4 on that side?
This 1/4?
Yeah.
Because the first thing I did is multiply by x minus 1 and let x equal 1.
Yeah, which canceled out x minus 1.
Yeah.
And you did 1 over 4 where you got that 1/4. And why does that negative 4 stay on that side? Because don't you do the same thing?
I do the same thing now to get b. I multiply by x plus 3,
Which cancels out the
x plus 3, and let x equal negative 3.
which gives you negative 1/4.
Correct.
Well, why is it on this side of the equal? Oh, okay. I see.
That's over here. And now on this side, what happens? This becomes a 0, and that becomes b by itself.
No, it just looks like as if it's all one equation. It's-
Well, there's two separate things. A is that, and then I turn around and solve for b.
Okay, now I get it.
Okay, good. That is the super fast way.
And then
No.
you just plug it in, and then you get then you find the integral.
Then the integral is always easy. On the test, I'm going to ask you for the sum of the two constants. I'm going to ask you for a plus b. That's what I'm going to ask you for. The answer, 0. Okay? All right, let's do a more difficult one.
Wait, so the answer for the test is going to be 0?
Yeah,
How?
because a plus b adds up to 0.
Oh, okay.
Okay, you ready?
But isn't it 1/4 over x minus 1 plus
Yes.
negative 1/4
Yes.
minus x plus 3?
Yes, that's the integral that you get. I'm not going to ask you for the integral. All I'm going to ask you for is the sum of the two constants.
Oh, okay.
Okay? I'm going to assume you can do the integral. The integrals are pretty simple. Maybe I should redo the test and make
Well,
you...
is it always going?
No, it's
No, it's not always going to be
I
0.
like the sum of the constants.
Yes, and it's not always going to be 0. Okay? I'm going to do a more difficult problem, all right?
Let's do it.
All right, maybe I should do another one of these linear factors.
No.
I was going to crank it up a little bit, and
We can handle it.
Danielle can handle it.
all right, here we go. All right, let's make it a little bit more difficult. Let's suppose we have this integral. Let's go with 2x plus 1.
You gotta put it down a little bit.
Okay,
Thank you.
you're welcome. Let's say that's x minus 2, and let's say this is x plus 1 squared. This is a much more difficult problem. Okay? Now, we're still going to take this, resolve it into its constituent fractions. We're going to use partial fractions. Here's the original. I'm going to have an x minus 2 as a possible denominator. It will get a constant. But because this is x plus 1 squared, it's a repeated linear factor. It's called a repeated linear factor. I have to take into account the possibility that we had an x plus 1 and an x plus 1 squared. Okay? In order to generate all the possibilities, in order to generate all the possibilities, I have to have an x plus 1 and an x plus 1 squared. If I don't have them both, I don't generate all the possibilities over here. Okay, so here's what I'm telling you. If you've got a repeated linear factor like this, you're going to have to start with the x plus 1 and then go to the x plus 1 squared. If, for some reason, this had been a cubed, then you would have an x minus 2. You would have an x plus 1. You'd have an x plus 1 squared, and you'd have a d over x plus 1 cubed. Okay? Because that's the only way to generate all the possibilities. Okay? Now, we're going to solve for a, b, and c, and we're going to end up with a problem. Okay? But let's see what happens. I'm going to do this the fast way. I'm not going to do this the long way because you end up with 3 equations and 3 unknowns, and it's a pain in the neck. I'm going to use the fast way as much as we can, but I'll show you what happens. You ready? Let's solve for a. How do you solve for a?
You put x to, you multiply by x minus 2, right?
You multiply by x minus 2, and then you let x equal?
2.
Perfect. This is gone.
Yes.
2 times x, 2 times 2 is 4, plus 1 is 5. Okay. 2 plus 1 is 3, squared is 9. Now what happens on this side? You're multiplying by x minus 2. That's gone. A is by itself. The b is getting multiplied by x minus 2. But you're letting x equal 2. That's multiplying by 0. That's gone. You're multiplying this by x minus 2. You're letting x equal 2. That is a 0. This is gone. A is 5/9. Done with A. Nice.
I don't really get,
Go ahead.
how that happened.
It's magic. I told you. You must have blinked. All right, here's what I'm doing.
I try not to.
All right, don't blink. Your little
Yeah, I get
toothpicks
the
to hold those eyelids open. What's that?
I get the A. Oh, wait. No, tell me.
Okay. Multiply both sides by x minus 2. This is gone. Let x equal 2. 5, 3 squared is 9. Got the 5/9 on that side? What happens on this side? When you multiply by x minus 2, this cancels out this x minus 2. A is sitting there all by itself.
Yeah.
Now, this guy gets multiplied by x minus 2, but then I'm going to let x equal 2. Well, x minus 2 when x is 2 is a 0. I'm multiplying this one by 0. It's gone now. And what happens to this one? Same thing. X minus 2, let x equal 2. It's gone. All right, let's see what happens if we solve for b. To solve for b, we're going to multiply both sides by
X plus 1.
x plus 1 and let x equal -1, right?
Yes.
Now what happens? Well, when we multiply by x plus 1, we only get rid of one of these x plus 1s, not both of them. And then when I turn around and let x equal -1, we've got a division by 0. We have a problem. I cannot solve for b the fast way. It doesn't work. Okay? It doesn't work. All right, well, all you can do at this point is now solve for c, and let's see what happens if we solve for c.
Wait,
Just-
so you just leave B out?
Right now, we're going to come back. We're going to get it. But right now, I can't solve for it the
If
fast
you have
way.
A and C, can't you get B?
Yeah, that's what's going to happen. Once I get A and C, I'll be able to get B. So, to get C, I'm going to multiply both sides by x plus 1 squared, the denominator, and then I'm going to let x equal -1. When x is -1 times 2 is -2, plus 1 is -1. -1 minus 2 is -3. Yeah, 1/3, changing the pluses. Now, I've multiplied by x plus 1 squared. Everything gets multiplied by x plus 1 squared, and then I'm going to let x equal -1. What happens here? X plus 1 squared, let x equal -1, you get a 0. This is gone. When I multiply this one by x plus 1 squared, one of the x plus 1s cancels, but the other one stays there, and I'm letting x equal -1, so I'm going to get a 0 there. Gone. When I multiply this by x plus 1 squared, both of those cancel. I get C. I have A and I have C. Now, we have to get B.
You just plug it in and find B.
Well, here's what we're going to do. That's what it amounts to. Here's what you're going to have to do. The lowest common denominator of these three is x minus 2, x plus 1 squared. The product of this with that. In other words, this A would have to get multiplied by x plus 1 squared. Okay? Numerator and denominator. The B, numerator and denominator, would have to get multiplied by x minus 2 and then x plus 1. Because I have to make this denominator x minus 2, x plus 1 squared. This numerator and denominator gets multiplied by an x minus 2. You with me on that? No? Vitaly? Was that a no? No, you're not. You shook your head no. Here's what I'm doing. The LCD of these three is x minus 2, x plus 1 squared. Okay? That's the LCD. That's the lowest common denominator. Okay?
Why don't you put x plus 1 squared in there?
What's that? I put x plus 1 squared because I have x plus 1 squared here. I need x plus 1 squared.
Oh, and then x plus 1 and just
X plus 1 is taken care of with this guy. Okay? What do? You take each factor to its highest exponent. That's how you find LCDs. Okay? Okay. Which means this numerator and denominator gets multiplied by x plus 1 squared to get this denominator to look like this. To get this denominator to look like this, I need to multiply numerator and denominator by x minus 2, x plus 1. And to get this denominator to look like this, I have to multiply this by x minus 2. All right, now here we go. You ready? If I were to multiply this out, I'm not going to, but if I were, I'd have an ax squared. I would have a bx squared. I wouldn't have any cx squares. How many x squares do I have over here? 0. That tells me that A plus B must be equal to 0. If A is 5/9, what is B? Negative 5/9.
Why would it be 0?
Because I don't have any x squares here. I've got 0 x squares. Yep.
So the numerator has to have x squared.
Well, this one has ax squares plus bx squares. This one has 0 x squares. Therefore, to be equal a plus b, my x squares over here must equal my x squares over here, must be 0. If this had been a 7x squared plus 2x plus 1, a plus b would add up to 7. And if a is 5/9, I'd have to solve for b by subtracting the 5/9 from 7. Okay? Whoa. I'm going to give you guys one to do. Okay? I'm going to give you one like this. See what you can do. All right? You got enough strength to do it? What's that?
The sum.
Oh, yeah, if I ask the sum on the test is 1/3. That is correct. And I'll tell you what. If in course compass you have to actually do the integrals, watch this. A is 5/9 over this. That's a 1 over u du form. Very simple integral. Natural log. B, negative 5/9 over this. Natural log. Very simple. C, 1/3 over this. U to the n form. Very simple integrals. The integrals are simple integrals. Okay? All right, I'm going to give you one. See what you come up with. All right, here we go. This is what?
Second one.
This is the second of the 3. The third one is the most complicated.
What is it called?
These are all partial fractions. Yep, these are all partial fractions. Here we go. Let's suppose we have x squared plus x over x minus 2 x plus 2 squared dx. Here's what I want you to do. I want you to figure out the sum of the constants, a plus b plus c. That's what I want. Go ahead. And I will even do it myself. Okay. Yikes.
the exponents.
When I was dealing with what?
So,
Oh, I just did it out. Whoops. Okay. That's kind of funny. Okay, hold on a second. The last one we did was right to here.
yeah, so you get the least common denominator. But
Yeah.
you're looking at the top and you have 2x squares on the right and 0x squares.
That is correct, on the left. You have an ax squared when you multiply it out, and you have a bx squared when you multiply it out. So you have a plus bx squares, you don't have any here.
Right,
So a plus b would be 0.
okay.
Now, the problem I gave you, that's not the case, because you do have x squares, so you got to make sure, okay. Okay. Oh, what do you think about the summer thing? I am here all summer. So if you had questions where you needed me to answer questions like face-to-face, I am here.
Do you know if your class is filled up yet?
Which one?
The calculus 3?
No classes are filled up because you haven't been able to sign up
Oh, we're
yet.
not allowed to sign up yet?
No. Monday, a week from today, is the first day people can sign up for classes.
Oh, I
April
thought,
6th.
I thought what his name said was, he said it was this week.
No, April 6th.
It's next week. You can meet with advisors. Advisors can take a schedule and make a schedule for you, but nothing is entered yet. All the classes have 0 students in them. You got this one?
I think so.
Here, did you get?
Oh, yeah, the sum, right. Well, that's what I got.
Ah, that's
Yeah.
perfect.
Okay.
Good. Nice. Nice.
I don't get, what do we do after we, get the LCD?
After you solve for 2 of the 3, right? You should have solved for A and C.
I got A and B.
Or you should solve for A and C. You can't solve for B yet. You can't solve for B.
Well, I think my B is different.
Oh, maybe you put it at the end or something. But once you do that and get your LC,
The x plus 2 is my C.
oh, the x plus 2 and not the x plus 2 squared?
No, I didn't get the C, that's what I'm saying. It's
Oh,
very-
okay. Then you multiply numerator and denominator by whatever's necessary to make each denominator your LCD.
Yeah, I got that, but
Okay?
then I don't know what to do after that.
Well, then you look at it and you say, okay, if I multiply the a out, I'm going to have an ax squared. And if you multiply the b out, now I don't know if your b has an x squared or not. It may not. Okay, then you do the c, it has an x squared. And you have a plus cx squares on the right-hand side. But how many x squares do you have on the left? You have 1 of them. Therefore, your a plus c is equal to 1. And if you know what a is, then you know what c is. Did you get it?
I'm just waiting, because I heard what you said about B, and it was just too confusing. Just wait for me. I might have done A and C wrong, but I tried.
A plus 1 is equal to 1? Why?
Because there's 1x squares on the left-hand side. I'm assuming your
Yeah.
c is the x squared, yeah.
Yes.
Okay.
No, my A is the x squared. My A and C are the x squared.
Okay, so a plus c is equal to 1. And you know what a is, so you know what c is now.
How do you know A plus C is equal to 1?
Because there are 1x squares on the left-hand side. In that numerator here, there's x squared plus x. It's 1x squared.
Oh, it's just the opposite. That's right. So you just plug it in and find the integral.
Well, yeah, but don't even do the integral. Just add up the constants. That's all I'm going to ask you for in the test. The integrals themselves are pretty simple.
Could you go over with the A plus C, why it's 1 again? I'm confused why it's 1.
I'm going to go over the whole problem. I'm going to go over it. Did you get it, Davey?
I think I got it right.
What? What? You're too hot?
What's after the,
Well, one more partial fraction kind of problem. Then L'Hopital's. Yes.
That's right. That, and all that.
Okay, A is 3. Okay, I agree with 3 A's. Negative 1/2. And no, I got a 5 A's.
How do you have 5 8?
Oh, because they add up to 1.
Yeah, but if you do 6. Oh, I see what I did. It wasn't half. That's what it was.
Okay.
I see what I did wrong.
Yeah, all right, no problem. All right, you guys ready?
You got negative 1/2? I got positive.
You got negative 1/2 for C?
For this one,
What'd you get?
I got positive.
Oh, I got negative.
for this particular one and the one before, A, so C is always going to be the opposite of A.
No. The one before, it C is the opposite of A because there were no x squares. But this one, A plus C must add up to 1, so they're not opposites. Okay? So you ready? Vitaly, you got this? Yeah. All right, here we go. You ready? Here, let's do it. So I'm going to take x squared plus x over x minus 2, x plus 2 squared. And I'm going to have an A over x minus 2. I'm going to have a b over x plus 2. And I'm going to have a c over x plus 2 squared. Okay? Solving for A, not a problem. Multiply by x minus 2 and let x equal 2. 2 squared is 4. Plus 2 is 6. 2 plus 2 is 4. Squared is 16. That gives me 3/8 for A. Done. B, I cannot solve for. I cannot solve for B because when I multiply by x plus 2, it gets rid of only one of these x plus 2's. I still have an x plus 2 in the denominator, and when I turn around to let x equal negative 2, I've got a division by 0, and that's not good. Okay? I can't solve for B right now. But I can solve for C. I'm going to multiply by x plus 2 squared and let x equal negative 2. Negative 2 squared is 4, plus negative 2 is 2. Okay. This is gone. Negative 2 minus 2 is negative 4. That's negative 1/2, and that's C. Check it out. Make sure it's okay. Okay. Now, okay. Everybody okay? You okay? Okay. B. How am I going to solve for B? I'm forced to do this. I'm going to multiply this numerator and denominator by x plus 2 squared. I'm going to multiply this numerator and denominator by x minus 2 and an x plus 2. This numerator and denominator gets multiplied by x minus 2. I'm going to look at the x squares. Could you look at the x's? Sure. Could you look at the constants? Sure. The only reason I'm looking at x squares is because it's very simple to see that I've got a plus b of the x squares. I don't have any x squares here. So it's the easiest one to do. A plus b x squared here, I have 1 x squared over here. That tells me that a plus b is equal to 1.
Can you go over that again?
Yes. I have 1 x squared on the left. I have a plus b of them on the right. When I add these up, I'm going to have an a plus b x squared plus some other stuff. Well, I've got 1 x squared on the left-hand side. I have a plus b x squared on the right. I've got to set those equal to each other. Because my x squared on the left, 1, must equal my x squares on the right, a plus b. So a plus b must equal 1. I already know what a is. It's 3/8. Subtract the 3/8 from 1 to get b is equal to 5/8. Okay? I'm going to ask for the sum of those. Okay? The sum of this plus this plus this is 1/2. That's what it's going to be in the test. Okay? And I'll tell you what, on the test, I'm going to give you 3 partial fraction problems. The first one is like what we did before. 2 linear factors, pretty simple. The second one is like this here. And the third one is what I'm going to give you right now. Okay, you ready? Let's do it. The third one involves this situation.
Wait,
Whoa! What?
quickly. On the test, is a plus b going to equal 1? Or even
No. It's not a. It's a plus b will equal the coefficient of the x squared term if it's a problem like this. Whatever that coefficient is. It may be 0, it may be 1, it may be 7, it may be anything at all. Okay. All right. Last one.
So if it was like 2x squared, then it would be a plus b equals 2?
Yep.
Okay.
All right, the last one involves a problem like this. Okay, this x squared plus 4 is called an irreducible quadratic. Okay, irreducible quadratic means it can't be factored. You have the sum of two squares. Okay, if this had been an x squared minus 4, you would immediately factor it into x plus 4, x minus 4, and then you have three linear factors, which would be pretty simple to solve. A over the first, B over the second, C over the third, not a big deal. But it's an irreducible quadratic. You cannot factor this, okay? We're going to still use partial fractions, but it's a little bit more complicated because what we have is this now. This x minus 1 linear factor still gets a constant. But the quadratic factor gets a bx plus c. We need to do that to generate all the possibilities. It's just the way it is.
Is that like linear?
Yeah, this is a linear over this second degree. Yeah.
You have to put it down a little bit.
Oh, I'm off the top.
Oh, did you record that?
I'm over, yeah, okay, I'm in that.
Oh, I got lost with the bx plus c.
What I'm saying is if you have an irreducible quadratic, it will get a linear term in its numerator. If you got an x squared plus 4 or any other quadratic that can't be factored, you're going to get a bx plus c here, always. Okay? Now, let's see what we have. In order to, we can solve for a. That's not a big deal. Let's solve for a. Multiply by x minus 1. Let x equal 1. I get 3. 1 squared is what? Fifths. That's a. Nice. Very simple. Yes?
But is it not factorable? Couldn't you do like x minus 2 and then x plus 2 or something?
And that would be x squared minus 4. You can't factor it.
Okay.
Okay? You're going to have to trust me, understand. All right. So, and therein lies the problem. How am I going to solve for b and c? If I multiply by x squared plus 4, what am I going to let x be to make that a 0? 2i? That's the only way you're going to get a 0 out of there is use imaginary numbers. And I actually went to a talk once. University of Texas guy was advocating that we use the imaginary numbers right here to solve for b and c. But it was 10 times more difficult than what I'm going to show you. So that was ridiculous. It was absurd. But I guess his point was it could be done that way. Okay? Now, how was it?
Stand up and tell me he's wrong.
No, I did not, because everybody in the room knew that the usual way of doing it was the correct way of doing it. And it was obvious. And sometimes at those conferences, I love going to those, but sometimes I can be kind of a pain in the neck. But anyhow, it was at one of those conferences that I made Stephen Wolfram laugh, like I told you, where he was up there, a keynote speaker guy. But anyhow, I'd love to go. I should go to more of those conferences. It's a good time. All right, but anyhow.
You get paid for those conferences?
They pay you. They will pay your transportation and they'll give you a meal allowance.
Is it in Florida?
Yeah, it's all over the place. That one was in New Orleans. That was nice.
You should do that one time.
I know. I haven't gone in a lot of years, too. I should
Is
go.
that why like half the bathrooms are like empty?
Oh, yeah, because, Vanessa and Donna and those guys go to these conferences all the time. And they suck up all the funds and they go all the time. And Professor Brewer, too, gets in on it.
It's like at my dad's company, they go teach the smaller companies in the area. Sorry.
Yeah.
And
They go on these
They go
conferences.
to like Puerto Rico. And
Yeah, we don't go to.
After work, they're on the beach.
Yeah. All right, well, here's A. Now, here's the problem. We can't get B and C because we can't get an X. That causes that to be 0. So here's what we're going to have to do. We're going to have to do what we just did. What would this have to get multiplied by? X squared plus 4. Because the LCD here is the product of these two. This guy has to get multiplied by x minus 1. Okay? Now, unfortunately, we've got 2 to solve for, B and C. Before we only had 1, it was pretty simple. Now we got 2. Okay, but we can do it. Let's look at the squares. I have an ax squared. I'll have a bx squared. I won't have any cx squared. When you multiply this out, you will not get a cx squared. You'll have a cx and you'll have a minus c, but no cx squares. I'll have an ax squared and a bx squared. How many x squares do I have over here? 0. If a is 3/5, what's b? You bet it is. Okay? You bet it is. Because a plus b must be 0 in this case because I have no x squares. Now, let's take a look at the c's. To do the c's, let's look at the constants now. I've got 4a here. The b has an x attached to it. Okay? There's no b's in the constants. I got a bx squared if I multiply this out, and I'll have a minus bx. But b never occurs by itself. It's not part of the constants. But the c is multiplied by the minus 1 here, so it's a negative c or minus c. Okay, when you multiply this out, you'll have minus c.
Where'd you get the 4a?
The 4a is from here. I'm looking at the constants. When you multiply this out, you get ax squared, and you get a 4a.
Where'd the x go?
Why do you ignore the x squared, the ax squared?
Well, we already used the ax squared to get to the b part. What I need to do now is solve for c. And the question is, how do you solve for c? Well, c is involved with the x, and it's involved with the 1, with the constant. The easiest thing to do here is to solve for c when you only got 2 of these unknowns. And I can see that, well, I could do the x. But the a is times 4, so there's a constant 4a. The c is times the 1, so it's minus c. And what's my constant here is 1. All right, do you see that all right? I could have done it this way. Now, just watch this. I could have said, okay, let me do the x's. When I multiply this out, there's no ax. When I multiply this out, I'll have a minus bx minus plus, rather, cx on the x's. And how many x's do I have? It's 2. I have 2 x's. Actually, in real life, I only have 1 x, but anyhow. All right, so substitute this in for a. If you substitute for a, the 3/5 equals 1. I've got 12/5 minus c equals 1. Bring the c over, subtract the 1. I'll have 7/5 will be c. You with me on that? That's using this one. If I chose to use the x's, you don't have to do both. You do one or the other. I'm doing both. You get the opposite of b, which is 3/5, plus c is equal to 2. Subtract the 3/5 from each side. This is 10/5 minus 3/5. You get 7/5. So either case, you're going to get the same answer of 7/5. One, I use the constants. The other, I use the x's. Doesn't really matter. Okay? Now, yeah, I will in a minute. I just want to point this out. The integrals that you get, I'm not going to ask you to do the integrals on this, but web assign may. When you have the integral of a over x minus 1, it's easy. It's 1 over u du form, natural log. When you have the bx over x squared plus 4, that's a 1 over u du form as well. U is x squared plus 4, the du is 2x dx. Well, you got a bx, so you can do that. But what's the integral of c, 7/5 over x squared plus 4? What's that integral?
Tangent.
Thank you. It's an inverse tangent. Okay, and that's what it would be, an inverse tangent form. Which you could do, by the way, with a trig substitution. Okay? Just pointing that out.
Question.
Yes?
I know this is kind of going back. How do you get the negative 3/5 for b?
I got the b by looking at this and looking at the x squares. Ax squared is what I have here. I'll have a bx squared here. I don't have any x squares over here. I'll have a plus bx squares over here. A plus B therefore must be 0, since I don't have any x squares there. So they must add up to 0.
Because there's no x squared on the other side.
Correct.
If it was, if they were both, if on the right side they were both x, not x squared, then that'd be 2, right?
Yeah, if you were looking at the x's, the sum of the x's would be 2. That's what happened here. When I was looking at the x's, the negative b x and the cx add up to these 2 x's. That's how I got this 2, from this 2 here. I'm going to give you one. You ready?
No, that's up.
We can do it. All right, here you go. Solve for the sum. Find the sum of the constants. Go ahead. Do. Wow. Okay. Wow, this is really weird. Okay. We're getting there. Damien's amused. Either that or he's overtired. What are you are? What'd you guys do today in her class?
So we're still doing what we did last week here.
Trig integrals?
Substitution,
Trig substitution, yeah.
lots of practice.
Yeah, that's probably a good thing. That's one luxury you have meeting 5 days a week.
That's why they have the 5-day week.
Yeah. Yeah. Okay. Good. Perfect.
Then I did what you said like that.
Whoa,
What
perfect.
does it equal?
Well-
Why does it equal 1? Is what I mean.
Okay, because you got these by looking at the constants, 9a and minus 2c. What's your constant here? 1. Right there. That's why it's equal to 1. It's perfect so far, Danielle.
And A plus B equals 1 because there's no coefficient right here? Is
Yes.
that correct? Okay.
Oh, because the coefficient is 1. Yeah.
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 And like when one of the exponents here is higher than this one, then it will be 0.
Wait, say that again
Like,
now?
let's say this was like x cubed.
It won't be.
Oh.
It just won't be.
Okay.
It won't be. If it is, you got a problem.
What if it's x to the 4?
It won't be.
So it's just, okay, never mind.
Don't even think about that. You won't get that. That is not within the realm of possibilities here.
Burns.
Yes, me. What?
Yes.
You're
It's hard
stuck?
to believe, but I am.
I find that very difficult to believe.
You got
I
it.
like your sarcasm.
What are you stuck with?
I'm stuck at the last part where you're getting C.
Ah, I got it. Yep, C. Okay. I found C by looking at the constants. I got to tell you, for the C, what I have is a 9a minus 2c equals 1.
minus 2c.
equals 1, yes.
How do you find that?
Could you do it by the x's too, if you did?
You could do the x's. The x's aren't too bad because you're going to get negative 2bx plus a cx, and you have 0 x's over there. That's not bad at all, really. That's a pretty good way. All right, what was your question, Nick?
I'm confused. How did you get that 9x?
9a, because the a gets multiplied by x squared plus 9.
Oh, you have to do it the whole thing.
Well, you got it. Yeah.
So a squared plus 9?
No. You get x squared plus 9 times the a.
Which you get 9a.
Yes, that's where I get the 9a.
So you just get rid of the x's? Is that what you're saying?
Well, I'm looking at the constants. The x squared I don't care about now. All I want to do is look at the constants, and I have a 9a.
Oh, 9a.
And then on the other side for the constant, I have a minus 2c.
Wouldn't it be minus 2b?
I don't even use the b because b has an x attached to it, so it can't be part of the constants.
Okay, so minus
16 thirteenths.
And what do you do to
Yeah, I probably didn't
what do you
simplify
equal it to?
What's that?
What do you equal it to?
1, the constant on the left-hand side.
So, but there's 2 x's on the, the one constant.
Yes.
So if it was, say, plus 10, the constant would be 10, right?
Yep.
Okay.
How are we doing? Do. How are we doing? All right? Oh, wait, Damien.
I don't think it was that bad.
Good. Okay. Who wants more time?
I do.
Okay. We're getting there. We'll be done, 8 o'clock.
No, we'll be done before that.
Well, we got L'Hôpital's, yeah.
What is L'Hôpital?
L'Hôpital. L'Hôpital is a mathematician, French mathematician, really 1700s or so. He came up with a rule for evaluating certain kinds of limits.
Do they have like
Is he French?
math?
Yes.
Is he relative to Topier?
Could be. Who knows? Go ahead. What were you saying, Damien?
Oh, do they have like a math history course?
They should. We talk about that every so often to offer a math history. We don't think enough people would take it. But you could make you could vary the degree of the difficulty of this math history course. There are some very good math history books where you do problems that were done in the time period. Like you can do problems that were done at 200 BC, the way the Greeks would have done them, or do problems in 1500, the way Fermat may have done it with the tools at hand, that kind of stuff. And you can make it very complicated. As a matter of fact, as a math major, you would definitely take a math history course. That was one of the most interesting courses I took because I did. What's that?
What's it called?
What's it called? Math history.
Oh, that's it.
Yeah, it was at UMass. Yeah, we don't have it here. It would be interesting to do, though.
Doesn't seem like too complex to teach, does it?
No. You have to really know the math history, though. And so, there'd only be one of us able to teach it.
You're having a monopoly.
No, there'd be, math history is good stuff, really. All right, you guys ready?
We're ready. Yeah, he's helping.
Okay, that's all right. Who wants more time? We all set? Let's take a look. Here we go. We're going to take this x squared plus 1, x minus 1, x squared plus 9, and we're going to have a constant over the x minus 2, but then we need a linear term, bx plus c, over the x squared plus 9. Okay? Solving for a, not a problem. Multiply by x minus 2, let x equal 2. 2 squared is 4 plus 1 is 5. 2 squared is 4 plus 9 is 13. We get a. B and C are not so easy. We're going to have to multiply this numerator and denominator by x squared plus 9 to get our common denominator, which is their product. This bx plus c would have to get multiplied by x minus 2. Now, when I multiply this out, I'll have an ax squared, I'll have a bx squared. I won't have any cx squares. I have 1x squared over here. That tells me that a plus b is equal to 1. And if a is 5/13, that tells me that b must be 8/13. So their sum is equal to 1. Now I know b. To find c, I would use the constants. I have 9a here, but what Trent said was to use x's, which is not a bad idea at all, because you have 0 x's here, and that's kind of nice. I would still do the constants, but it's your call. I have 9a plus a minus 2c, or negative 2c. That's equal to the constant 1. 9a, that's 45/13 minus 2c equals 1. Add 2c, subtract the 1, you get 32/13 when you subtract 1, 13/13 from 45/13. That's equal to 2c. Divide by 2, c would be 16/13. Okay? So you have A, B, and C. How's it look? Hey, let's go. Go on. No, not yet. We got one more topic. One more topic, and this is l'hôpital.
I like the way you say it. L'hôpital.
L'hôpital. Well, that's what it is. That's an L. That's an axon circumflex about the O.
Is his name hospital?
Yes. That axon circumflex often replaces an S. Okay? It is a hospital. That was his name. Okay?
That's an odd name. Is it his first name?
I don't know what his first name was.
Hospital.
L'hôpital. Anyhow, he said this. If take the limit as x approaches c of f of x over g of x is equal to 0 over 0 or infinity over infinity. If you get one of those two indeterminate forms, okay, either one of those two, then the limit of x approaches c of f of x over g of x is equal to the limit as x approaches c of f prime of x over g prime of x. Now, a quotient rule, you take the derivative of the numerator over the derivative of the denominator. For example, let's suppose we have this limit. This is a limit you do in Calc 1. You do a proof, usually, of this limit. Okay? The proof of this limit is one that involves areas. You have a quarter circle, you draw a line segment, and you have 3 areas. You compare and use a squeeze theorem to show that this limit is equal to 1. And then you use that limit to get the derivative of sine. Okay? But this is, let's see what's going on. Where's the numerator going? As theta goes to 0, what happens to the sine of theta? 0. It goes to 0. The denominator is going to 0. We have a 0 over 0 indeterminate form. Therefore, we can use L'Hopital's and take the derivative of the numerator over the derivative of the denominator. And now let's see what happens. As theta goes to 0, where's cosine going? 1. You get 1. Okay? And that's the answer. Okay? It's kind of nice.
Oh, wait.
Go ahead.
Technically, it's sine theta over theta is 1 anyway.
Yeah, we knew that limit. We did it by a big long proof, though, with areas and a circle. This gives it to you immediately. Let's do another one. Let's do the limit as x approaches.
Why did we do this last semester?
What's that?
Why did we do this last?
I don't know.
They want you to struggle.
Yeah, because it's stupid here. It's ridiculous in this chapter. It's like they could. I don't know. I really don't know. I never knew why it's stuck right where it is here.
This is pointless.
It's well, this is what it is. All right, so let's do this problem. 3x squared plus 5x plus 10 over 4x squared minus 2x plus 7 Where's the numerator going as x goes to infinity? Infinity. Where's the denominator going as x goes to infinity? Infinity. We have infinity over infinity in indeterminate form. We can use L'Hopital's. Take the derivative. The derivative of this is 6x. The derivative of this is 5. Derivative of 10 is 0. Take the derivative, 8x. Derivative is 2. Now where's the numerator going? Infinity. Where's the denominator going? Infinity. We use L'Hopital's again. Take the derivative. Take the derivative. Now we get 6/8, which is equal to 3/4. Whoa.
Wait, how does that look?
What's that?
What does that give you as an answer to that?
It gives me the answer of 3/4.
Are you just finding the derivative? That's all it comes out to.
How does it look on the map? Where does the, I mean on the graph, where does it come
On the graph, if you, if you were to graph this quotient thing here, tell you what happens. I don't know what happens when x is small, but I do know this. When x increases without bound, this thing is going to approach asymptotically 3/4. You're going to get a horizontal asymptote at 3/4. So it may do strange things here, but eventually it's going to settle down and approach 3/4. That's what's going to happen. Now, one other thing I should point out here. When these two degrees are the same, you should have learned in Calc 1 that limit is the ratio of their leading coefficients, 3/4, which is what we got here.
Oh, that's right.
What's that? Yeah. Well, there's one other application, though, I've got to show you of L'Hopital's. What's that? One more thing we got to do. And that is this problem. Find this limit. Let's do... I want to go to infinity here. Make that infinity.
1 plus 1 over infinity.
Yeah, we got 1 plus 1 over h to the h power as h goes to infinity.
Wow. Equals infinity.
Well, let's see. 1 over h, where's that going as h goes to infinity? 0. Inside the parentheses, therefore, is going to where? 1. The exponent's going to infinity. We end up with 1 to the infinity indeterminate form. And what makes this indeterminate is this is not exactly equal to 1. If you had this problem, that answer is 1. If that's identically 1, if that's just 1, I don't care what happens to h. H can do whatever it wants. That's going to equal 1. That limit will be 1. But because this is getting closer to 1 and not equal to 1, and we raise that to this exponent h, we have what's called a 1 to the infinity indeterminate form. This could be anything. It all depends. Is this getting to 1 faster than that's increasing? Or if it is, then maybe the limit is 1. But if this is taking its time getting to 1 and this is increasing faster, maybe the whole thing goes to infinity. Or maybe it goes somewhere in between. Now, do we have a 0 over 0 infinity over infinity indeterminate form? No, we do not. What the heck? We don't have one of those forms. We're going to have to do something to get to an L'Hopital's form. And here's what we're going to do. We're not going to do this problem. We're going to do this problem. We're going to take the natural log of this expression. Now, if I can determine what happens to the natural log of this expression, then I can tell you what happens to the expression. In other words, let's suppose we can prove that this limit is equal to 7. Well, the natural log of what number is equal to 7? The natural log of what is equal to 7? Maybe that's too tough. E to the 7th, okay? The natural log of e to the 7th would be 7. Because what is the natural log? What is any log? It's the exponent that you raise the base to get the number. So if I can find out what this limit is, then I can find out what that limit is by taking e to that exponent. Okay? Now let's see what I have. I have h going to infinity. This is going to 0. This is going to 1. I have the natural log of 1, which is 0. And I have h going to infinity. I have a 0 to the infinity indeterminate form. All depends on who's getting there first. Okay? Well, let's change it. Let's bring this h out front. That's one of the properties of logs.
How'd you get the log?
I just took it. I just took it there. I took it because I couldn't do this problem, so I said, okay, I can't do this problem. Let me try this problem instead. I just did it. I just did it, didn't I? All right? So if I can answer this question, I will be able to answer that question. Now, I'm going to take the h out front. Now, let's see what we have. H is going to go to infinity. We got infinity. H is going to go to infinity. 1 over h is going to 0. The natural log of 1 is 0. I have 0 times infinity. What's 0 times infinity?
0.
No, it's indeterminate. It all depends on who gets there first. I get something increasing without bound, something going to 0. If this guy's increasing faster than this guy's going to 0, it may be infinite. But if this guy's going to 0 faster than this guy's increasing, it may be 0. Or it may be somewhere in between. The point is, I don't have L'Hopital's yet. But let me do one other thing.
Oh, so you're trying to prove.
I'm trying to get this so I can use L'Hopital's. Watch this. I'm going to divide numerator and denominator by h. Okay? The denominator here is 1. I'm going to divide numerator and denominator by h. That'll cancel this h. And the denominator will be 1 over h. So what I'm saying is instead of multiplying by h, I'm dividing by its reciprocal, which is the same thing as multiplying by h. Now let's see what we have. H is going to go to infinity. 1 over infinity, 0. Natural log of 1, 0. 1 over h is going to infinity. What's that equal to? 0. We got 0 over 0 in determinate form. I can now use L'Hopital's.
Oh, we took a half off.
Well, he said it was going to take a half.
I did say that. But we're going to be done well within now. We're almost there right now. So here, I don't even need another piece of paper. Okay? I shouldn't have written it like this, though. Here we go. I'm going to use L'Hopital's on this, and that means what I can do is take the derivative of the numerator, take the derivative of this, which is 1 over 1 plus 1 over h, times the derivative natural log u is 1 over u du dx. The derivative of this expression. And the derivative of this expression, derivative of 1 is 0. The derivative of 1 over h is a negative 1 over h squared. Ooh, you guys got to check that out. It's a natural log u form, the derivative of which is 1 over u du dx. The derivative of 1, 0. The derivative of 1 over h, negative 1 over h squared. Because the derivative of 1 over h is h to the negative first. Its derivative is negative 1, h to the negative second. Yeah.
So why do you have 1 over 1 plus 1h?
Because the derivative natural log u is 1 over u,
Okay.
and then du dx. Okay? Now, what's the derivative of 1 over h? I just said it was negative 1 over h squared. Okay? What can I do here? Cancel. H is going to go to infinity. Where's 1 over h going to go? 0. I get 1 over 1, which is 1. Now, the answer to the original question? You still see it? Yep. The answer to the original question, therefore, here's what I know. I know the natural log of this expression is going to 1. Therefore, this expression must be going to e. And one of the things you do in Calc 1 is do this where you show as h goes to infinity, 1 plus 1 over h to the h gets closer and closer to 2.718281828459045223, etc. e. That's one of the things you do. You don't do the proof, but you see that it's reasonable by doing it on a calculator, okay? And you can see that you're getting closer and closer to that number. That's a proof, though, that that limit is
So
d
why does it
equal
go
to
to
e.
I'm sorry.
It goes to e because its natural log goes to 1. And the number whose natural log is 1 is e. Okay. I'm just showing you, here's a case. You don't have L'Hopital's immediately, but you can work to get there. Now, on the test, I'm not going to give you one like that. I'll give you some easy ones to do, underhand. Wait, softball? You haven't started yet, have you?
We're indoors right now.
Oh, you're indoors? But you haven't actually played a game against anybody
We're
yet?
playing the 4th. We have like a scrimmage against Turner Falls.
Really? I gotta watch one of
They
the
might
games.
cancel it.
Oh, yeah, it'll still be snowing around. That's it!
It shouldn't be snowing though. It's spring, so I don't know what's
Yeah, right.
happening here.
All right, so that is, I don't know, that's L'Hopital's, whatever that is.
Let me do this.
Okay, you can do
Are
that.
they in order?
Yes.
But our first